Hi, welcome to STL, the 3D Printing Digital Fabrication Podcast. My name is Scott Rocca.
I'm Basilis.
And I'm Ryan.
Thanks for joining us today. We got a couple things that we're going to talk about. We're actually kind of looking at metal printing. So it's not just printing in metal, but we're also looking at lost material casting process. So whether that's lost wax, PLA, ABS, which is a terrible idea, and so on and so forth. We're looking at some of that kind of stuff today. One of the first processes that we want to talk about was...
You want to talk about the solder one?
Yeah, let's talk about solder one.
Sure.
So, let's...
Too many conflicting things. Okay.
Yeah, so somebody put together a solder-based 3D printer using tin solder?
Yep.
Yeah,
Super
tin.
solder? Tin? All right. And he managed to get it out working, and as far as I know, you can only get it down to about a millimeter before it starts breaking down and freezes.
15 millimeters of 3 millimeter feed.
Got it.
Yeah. And, I mean, that kind of stuff, you don't necessarily have to worry about it jamming with your whatever kind of gear you're using, because, solder, it's going to match it. It's going to match the gear. It's going to compress really well. So that's not necessarily going to be an issue. Your issue, the thing you're really going to run into is that once you get up higher away from the bed, you're losing some of your heat.
Yeah.
So I think that that's really where you're going to run into those issues. And it's because once he's getting that little distance away from the bed, which is heated, I'm betting, he's losing heat.
It's not a heated bed. He's just running on a straight up Mendel.
Okay.
He's just running it through an extruder.
Oh, yeah. Just fed the stuff straight in.
Yeah, it's a Budish nozzle.
Yeah. Because I remember them talking, he was using 3 mil that he picked up from McMaster, and he's going to change it down to 175 because he thinks that he might have a little bit better flow rate with that.
You'll be able to heat up fast. Well, not faster, but you'll lose heat slower.
Yeah, exactly. Because you'll have a slightly more thermal mass.
Yeah. Thermal mass is good.
Yes. I mean, I'd be interested to see, I didn't look at the extruder nozzle close enough.
It's a Budish nozzle.
I know it's a Budish nozzle, but I mean,
one.
is it wrapped? That's what I was getting at.
It doesn't look like it.
Okay.
No.
Yeah, because I mean, that wrapping it alone would actually help as well. Because, I mean, you'll contain the heat better.
Yeah.
And then you don't have to worry about heat loss as much, especially if you're going to start getting solder around the tip that's starting to cure. Anyway.
Well, you're going to end up with the problem of having solder come back to wherever it's hot, right?
No.
Not necessarily.
It's a lot like how the plastic is done. It's you melt it just right below, like right at the point of the melting.
Yeah.
And
you're going to melt it at its flow temp instead of...
that's the word I was looking for.
Yeah. You're going to melt it at the flow temp instead of at the full melting temp. So then that way you're making it melt just enough to where it's liquid for long enough to be put down in a specific area.
So you're just making it tacky.
Pretty much, yeah.
Gotcha.
So, I mean, that one was really cool. It's going to be interesting to see how he progresses with that. Yeah, he's printing in tin solder, but still, it's an interesting little process to kind of see what people are experimenting with and stuff like that. The other one was an open source, what they're calling metal printing, but it's not. It's actually, they're printing in wax using an SLS laser sintering method. So what they're doing is, if you ever looked at the way laser sintering actually works, it's a powdered material that is heated, and then they use a laser to kick it over to the melting temp so that they can fuse layers together. And layer height, the smallest layer height anyway, is generally dictated by the granule size. So however small you can grind this stuff down. And wax you can get pretty damn small.
Oh, yeah.
Which is great. So, I mean, this guy has a DIY printer that can do laser sintering in wax. And so he's taking that and he's putting investment around it. And that's kind of like an art metalsmith kind of term, investment. It's not like you're going down to the bank and investing something. It's what you're doing is you take a combination of plaster Paris and playground sand. And I believe it's around a 1-to-1 mix, and there's different mixes for different things that you do. But what you'll do is you'll mix the two together, and you pour that around your object. And this is way oversimplification. If you really want, you can go out and you can look up lost wax casting methods, and there's going to be a plethora. But you have that, you'll have a spout, you pour in your metal, but before you do that, you actually bake the plaster of Paris and sand combination, and it will, once it's hardened, you bake it so you get all your moisture out, and then you also are going to be getting out the wax, because the wax will reflow and it'll evaporate, which is what you want. So then you're just left with a cavity that's going to be the exact thing that you sintered. So, I mean, these guys are using this method, and it looks like it's given them quite a bit of success so far.
I'm surprised that they're doing SLS with wax, but I mean, it's really cool that they are.
Yeah. And, you know, you can do a lot of stuff with that from there. And
I wonder if you could do that with a Blu-ray diode.
I don't know if you can, because I don't know if the wattage is high enough. But I bet you could probably do wax, or...
Well, if you make the focus small enough, it could work.
Yeah.
Yeah.
Which would then, in turn, give you high resolution, but that means it's going to take more time.
You get rid of the kerf.
Yeah.
Yep.
Not the kerf, you know what I mean. Hopefully you all know what we mean. That's the goal of this podcast. But yeah, this is a process that you can do also with PLA, and as you said, ABS, but
also nylon?
You don't want to do nylon. The same reasons why you don't want to do nylon and ABS. Nylon has poison and soft gassing. PLA, not so much. ABS, not as bad as nylon, but that's one of the restrictions why we're not using that material currently.
Cool.
But yeah, there's a neat documentation by a guy who was making a CNC machine, and he did lost PLA casting, and he figured out very quickly on what he had to scale up and what he had to scale down due to shrinkage of the final part, because when metal's a liquid, it's a larger volume. It takes up a larger volume, kind of. And then when it cools, it'll shrink down. Kind of like, heat makes things grow, cold makes things shrink.
And those of you who do backyard metal casting have to make their patterns larger by about 20% anyway.
Yeah.
Yeah, and this is account for shrink, and then not just shrink of your metal, but then also you have to worry about what's going to happen with the mold, did everything compress, so on and so forth.
Right.
And
yeah.
it takes a little bit of...
it's as art much of the science, especially if you're doing it by hand.
Yeah.
If you watch Adam Savage talk about his Maltese Falcon, there's a good point where he's like, I didn't account for the mold shrink. So he has a tinier Falcon than it actually is. He has a real one now that's right size, but just talking, like, that's a failure that's common.
It's one of the things you learn while you do.
Yep.
But there is a lot of good documentation about that out there if you want to read up on it before you take the plunge and decide to make a shrunken Falcon, as it were.
Yeah, you can make a bunch of failures, or you can spend, what is it? I'm not going to say stupid little sayings, but preparing for things is better than just failing multiple times. Do your homework. You'll do better.
So one of the other processes that you can also do is you can use a method like resin printing using something like the B9 or the Form Labs machines. The trick is you just need a burnable resin. So it's something that can burn out similar to the wax, whether it's a higher temperature or lower temperature, doesn't matter. But it's going to be the same process, just with a different manufacturing process to get that burnable object.
So hopefully not something with a lot of carbon in it.
Yeah.
Yeah.
So I mean, you can do a lot of different methods. And one of the other really cool things that we were going to try and move along to a little bit in just a second here, actually, because I thought of another point. With the resin printers and even some of the FDM normal 3D printers, you can actually print a casting tree, which is one of the things that takes sometimes hours to make. And so if you imagine all these little objects that we have down here on the front, lines connecting them all.
Sprues,
yes. So if you actually imagine an upside-down tree going to a single point, that's kind of what it is, and those are called sprues. And so what you can do is you can actually print everything with the sprues already attached, so that when you burn out all the wax, you have these paths for everything to follow. And doing that can take hours, and it can be very tedious work, and you can ruin some of your wax pieces or whatever you're burning out. You can ruin some of those by when you're going through and attaching the sprues, depending on how you do it. So this eliminates a factor of that process, which means that you're reducing cost and you're in man hours, and you're also reducing cost in materials.
You can also account for a lot more shrinkage with your sprues, especially if you can do it before you actually lay it out in your pattern.
Are you reducing cost by man hours? Well, you're turning man hours into machine time, which
Exactly.
I guess is cheaper.
Yeah.
Over the long term.
Especially if you're going to be doing multiples. So
Yeah.
like you can also do a much denser tree.
Yeah, because it doesn't care.
Yeah, exactly.
And much more accurate.
And you wouldn't have to do much cleaning with the support material. Like I know the B9C has a bunch of like sprue like support material stuff, so you could just have that be there, and it takes a little bit more finishing work, but it allows more paths for the metal to flow. I was thinking of another thing as you're talking about that. What happens if you do a low temp metal like Woods metal or just pewter and do a printed mold?
You could technically.
Yeah.
But if you were doing something like pewter, my concern would be how soft it is. And then you also have to worry about whether if flashing from whatever you're pouring in is going to fuse that together, because sometimes you're going to have to hit those molds to break them apart.
Use ABS. Drop them in acetone.
Yeah.
I don't know if pewter is immune to acetone, but it just melts right off.
Yeah. It probably is. I don't see acetone having really any effect on
No,
pewter,
pewter's
but
like tin and lead and
Yeah.
a bunch of other things.
I'm no chemist by any means.
I wonder if you can do lead. I don't know.
could-
That'd be interesting.
You could cast lead. Like, just dealing with a large amount of lead for either sintering or printing, I don't even want to think about. But the interesting thing actually is that you could get lead to melt down and turn into filament very easily. You just go down to Depot or one of your other hardware stores, and they sell lead sheets.
No.
You go down there and you buy a roll of lead sheet and melt it down.
Well, you can also, even cheaper than that, you go down to your auto parts store or your mechanic and you get the wheel weights they knock off when they're doing balancing.
Yeah.
What about, I know there's such a thing as a compressible metal gasket.
Yeah.
And
Those are usually copper, but sometimes they're lead.
I've seen lead, indium, and all sorts of wonderful things. As long as it's soft metal, they'll make it out of it.
Yep.
And I wonder if you just use solder for that. But you've got flux in there. If you could find a solid core solder, you'd be fine. Which is rare nowadays. Solid core
especially
lead.
with all the RHS stuff going on.
Yeah.
Oh, that goes back to the fucking thing we were talking about earlier.
Yeah.
Yeah.
How soon we forget.
Yes. How soon? Anyway, so moving on, there's another company called Vader.
Oh, Vader. Vader's cool.
Yeah,
Oh,
Vader,
yeah, we get
Vader
started
is really
with this.
cool. I actually had a chance to meet these guys at the World Maker Fair. Great guys, really nice. They had a lot of great input for my machine, which I'm very thankful for. It's a father and son team, isn't it?
Yeah.
Yeah.
That's what you kept saying.
Vader, father.
Anyway, enough Star Wars jokes.
Did he
Because
Well,
Disney will
German
sue us
jokes.
now. Oh.
Disney will sue us? Oh.
Yeah. Anyway, Vader, it's a really cool thing. And let's see here. It's liquid metal jet printing. So, just reading directly from their website, is a progressive form of 3D printing, also referred to as additive manufacturing, using a head much like that of an inkjet on paper. The machine lays down droplets and layers of molten aluminum that build up gradually. At the end of the process, the object of great complexity can be created with no labor and no energy on the part of the maker. So, I mean, that's a really cool thing to be able to print in aluminum.
Yeah.
Like, that's just, like, friggin' awesome.
Are they doing it in a vacuum, or is it just...
No, it's out in the open.
Okay.
The prototype machine that I was able to see at Maker Faire, it's
On their website?
it's on their website, vadersystems.com. And it was a neat little machine to just see there. And they didn't have it running, which if you're going to be using high-intensity lasers and metal and all that kind of stuff, you consider aluminum has a melting point of 1,300 degrees or so, I believe.
13 to
I
16.
don't know off the top of my head.
Yeah. So, I mean, you have something that's going to be
I can
running
look that up.
over 1,000 degrees. You don't really want to run it around
Oh,
the
come
public.
on. Why not?
Well, children. because
I don't plan to have children.
well, no, I mean other people's children, the children that are annoying.
No, they're not annoying because they're not coming home with you.
You kick them out of the shop.
Um,
Yeah, that's a pretty respectable build platform. Size 250, 250, 250.
yeah, I mean
It's
it's the start of the technology.
yeah.
It's the start of this branch of prototyping.
Well, one of the big questions I got looking at it is, do you just put bulk aluminum into the top and it just melts it down, or do you have to put in some sort of processed element?
From the looks of it,
It's got a funnel.
yeah, it's got a funnel on
That's
it.
what I'm hoping. You just kinda
I mean, I need to do more research into.
chop it up in cubes and stick it in there.
Yeah, the interesting. Like, I'd be interested to see if it can handle overhangs and all those other things like an SLS could.
Yeah, I mean,
Will it behave more like an FDM, or will it be able to do...
unfortunately, I wasn't able to get a chance to talk to the guys.
Well, they're probably busy as hell.
They were busy. I was really busy. The couple of times that I was wandering around, they were slammed. The couple times that they were wandering around, I was slammed. So I didn't get a chance to go and actually talk to them about their machine. When we did have a chance to speak, it was the night of getting everything set up the day before fair, and everybody was just running around crazy.
Yep.
But I mean, I'd really like to see more about it, and I want to know more about the machine itself. Just from looking at it, it looks like they have something that's actually being fed into the machine itself. I don't think it's a powdered material. It looks more like a filament.
Okay.
So like an aluminum wire, basically.
Makes sense.
And it'd probably end up having to be pure aluminum. I don't know if you can really have any filler or core.
Well, you could probably get if you take out pure aluminum, you could probably do it from the old houses.
Yeah.
Actually,
a lot of stuff that you can actually get it from is sculpting wire.
Yeah.
So it's armature wire. That's what I was looking for.
Oh.
Armature wire is almost pure aluminum because it needs to be malleable and it needs to be able malleable and rigid.
Right.
So that you can actually change the shape. You twist two pieces together, it's stronger, and you can get more complex forms out of it.
Sure.
So
and it's easy to cast, which is really nice.
Yeah. I mean, and it doesn't have to be exact because of what it's being used for.
No, wait.
What are you thinking about?
It casts very well. It turns up very shiny.
Yeah.
That's what pure aluminum does.
You can see the gears grinding, and there's some smoke coming out of one of his ears.
Yep.
But yeah, I mean, it's going to be really cool to keep an eye on Vader systems, and to kind of see what they do. And they have a couple of concept images up. They do have a prototype out. As far as I know, they're not selling yet, but I could be completely wrong.
It'd be interesting to see it run with the resolution they say they can get.
Yeah. It's going to be really cool to see how things progress. So, and guys, if you're watching this from Vader Systems, it was great meeting you guys. Hope to talk to you more.
Yeah.
So yeah, that's several of the different methods that you can do. So you can do, you can actually, the other option that we didn't actually talk much about too is that you can print a mold.
Yeah.
And so not just printing the aluminum mold like what the Vader guys can do, but using materials like polycarbonate even, or high impact polystyrene, something like that. Polystyrene is probably not the best option, but you can use other materials like that. Nylon would actually be interesting to do a mold of because it'll release really easily because it's a smooth material.
It's
self-lubricating. Yeah, it's
the off-gassing that you have to deal with.
Yeah, but I mean, if you're going to be producing molds and stuff like
You'll
that,
have the ability to counteract the off-gassing.
You should be set up enough to be able to take care of any kind of
ventilation and all sorts of other good stuff.
Yeah. So, I mean, do you guys have any other points to add to any of it?
I like metal printing.
Yeah. Actually, I do have one other thing. With one of our previous podcasts, we were talking about the Prusa and some of the prosthetics. It'd be interesting to see how the metal printing can actually interface with the prosthetics themselves. So being able to produce some of the more custom parts or things that are going to have to be more complex, like some of the springs and things like that, actually be able to produce spring steel.
Well, I don't think it'll be able to produce spring steel. There's a company who's doing SLS, like they did an SLS printed gun.
Yeah.
And they use store-bought springs.
Yeah.
Because it's just so much easier.
Or even one of the other things too is you could have the joints or bearings or things like that parts that need to move, and if you had the right tolerances, things like that.
It's not even tolerance. It's all material sciences too.
all material
Like you
science.
don't
Okay.
want to have like the bearings need to be a specific type of metal, and
Yeah.
the other parts have to be another thing.
Okay.
So you're going to have a multi material machine, and
Yeah.
it's like that's where it comes to an issue.
It comes back to Iron Man.
Well, if you had Tony Stark's wealth, you probably still couldn't do it nowadays.
No.
Like NASA's just getting into printing specialized rocket motors.
Oh, yeah.
Titanium, Inconel, all the ones that need to be printed in semi. Well, they're getting it down to where they actually print it out in what they call a triple F,
Yeah.
where they print it out using wire instead of having to have a bed of powder.
Mhm.
And so they're doing that with the electron beam sort
Okay.
of free form printing. Sort of like the solder, except more space agey.
Yeah. Yeah. Actually, there is an interesting machine too that it's one of the car companies. I want to say Ford is using.
Really?
It's if you've ever seen one of the old metal rollers that they actually it's the two balls that are actually just you can control how close
saw
they
that.
are, and you can
Yeah, it's
actually
the
roll
English
sheet metal. They have a version of that that's basically a Delta Bot. So what it'll do is it'll have a pad underneath the sheet metal, and it'll come down, and it'll actually start to press the parts out, so they can prototype out car parts like that.
Huh.
So another form of metal manufacturing through prototyping.
That's amazing.
But they were showing, there's a couple videos on that, and they're little 10-minute videos. And the process that they use and the technology, I could only imagine like some of the programming that went into that, because it would just be insane.
Yeah, some of the stuff that comes out of high-end industrial manufacturing is crazy.
Yeah.
And it should be.
Yeah.
Because they've had how many decades to build on it?
They've got the decades, they've got the money, they've got the
Yeah.
people.
Yeah.
Exactly.
And they keep it all to themselves, the bastards.
Well, until someone gets it.
So, do you guys have anything else to add on
Nope,
this?
I'm good.
or-
No, that's
Okay.
other than other stuff that I can't afford. Yeah.
Okay. And also, another fun fact, we are not podcasting under duress this week, because last week we were podcasting under threat of foam dart.
Oh, yeah.
Our
Our audience is too tired to stay.
yeah. We'll get some foam dart shot action coming back. Who knows, maybe we'll even set up a couple of targets for them. 'Cause
It really keeps you on your game.
It does. It does. And that was kind of like, you can be sitting here talking, and it's like, okay, I'm going to move this way so I don't get hit in the face by a couple of darts.
It keeps things moving.
Yeah. And speaking of keep moving, we're going to go ahead and move on. Thank you for joining us this week on STL Podcast. My name is Scott.
Basilisk?
And I'm Ryan.
Have a good night. No trolling!